All right, so our new unit is a unit called matrices, or using a thing called a matrix, and it's used in a lot of different things, but primarily you might think, okay, well, where can I find a practical application? And it might an easy one to kind of talk about would be something like a computer program, like a video game. Um, and the idea behind it would be and this is going to be a really simple thing because obviously they would get a lot more confusing if you're playing something like Call of Duty or Madden or something like that. But let's say you have something like this and you got three players. You got a player A, player B, and player C. And let's say they pass something back and forth. And let's say player A starts with it and passes whatever it is to player B. Player B passes it to C. Player C passes it back to B. Player B passes it to A. And player A passes it to C. And then you stop for whatever reason. One of the tough things about that is you couldn't possibly show that diagram in the computer program. You'd have to represent it in another way so that then on the screen you could tell the whatever it is on the screen to show this diagram or to show that this is a sequence that you want. One of the ways we can do it is we can organize this in what's called a matrix. And so let me back this out and so you can see the diagram at the same time. So let's say this is, you have A, B, and C here, and you got A, B, and C here. And let's say we just diagram this out and you kind of go, okay, this is going to represent who passes. And this is going to represent who receives. So, A can't pass to itself. So A is never going to pass to itself. B is never going to pass to itself. C is never going to pass to itself. But let's look at the sequences that we had. The first thing we did was, if we think about how many times did A pass to B? A passed to B one time. If you look at B passing to C, B passes to C one time. C passes to B. C passes to B one time. B passes to A one time. And A passes to C one time. And C never even passes it back to B. So we could put a 0 here. And let's say we add another one in. Let's say we add C passes it also back to B. Well, what that would do is if C passes it to B, that takes this one and moves it from 1 to 2. And so you could record all these things, and then depending on how it works, maybe something happens in the game after that. But that's a way you can diagram it. Now, in the practical sense, what we're going to do is we're not going to have these labels A, B, and C. What we're going to have is we're going to have them written like this: 0, 1, 0. This would be 1, 0, 2. This would be 1, 1, 2. And in this, these over here are going to be called rows. And these up here are going to be called columns. And you do it by rows and then by columns. So this is a 3-row by 3-column matrix. So we're going to do a little bit more work with this. So let me show you. Let me go back and pull some notes for you. Let me find it here. Got it on here somewhere. Okay, so here's how it's defined. Defines by rows then columns. Okay, the elements in it is this just the stuff in the matrix. So if we're going for what are the dimensions of this first one, this first one has 2 rows and 3 columns, so that's a 2 by 3 matrix. The next one is 2 rows, 2 columns, 2 by 2. You figure out what the next 2 are, and I'll write them down so you can pause, figure out what the next one is. Hopefully you wrote it. This is a 3 by 2. And then this final one sorry, whoops, I was about to write 3 by 3, but it's a 2 by 2 matrix. This last one is kind of a special one, just so you know. This one is called the identity matrix. It's special in that everything except for that diagonal is 0 and the diagonals are 1s. So that's something we're going to come back to a little bit later, but that's the identity matrix. You could write a 3 by 3 identity matrix, and it would be 1, 0, 0, 0, 1, 0, 0, 0, 1. This is a 3 by 3 identity matrix. So that's another identity matrix, just so you know. We'll come back to that in a couple of days. So we can add or subtract matrices, but only when they have the same size. We cannot add or subtract them unless they're the exact same size. And so if we add or subtract them, we're just going to add the places. So if we were going to add A plus B together, what we'd want to do is we'd want to do 3 plus 5 for that spot. We'd want to do 0 plus 1, negative 1 plus negative 3, and 5 plus 4. So we could simplify this into 8, 1, negative 4, 9. And so that's what A plus B is together. We can do the same kind of thing if we do but we can multiply it also. We can multiply it right out of the gate. So like if I want to know what is 2x equal to, 2x, if this is matrix x right there, 4, negative 6, negative 3, 0, then 2x, this would be 8, negative 12, negative 6, and 0. All I did is I multiplied everything in there by 2. So if I wanted to figure out what 3y is, because then I'm going to subtract these two, 3y would be 9 times 3, which is 27. Whoops, 27. 3 times 27 is 81. 3 times 0 is 0. 3 times negative 3 is negative 9. Now, if I wanted to then go on, and I wanted to say, okay, well now, what if I did 2x minus 3y? Well, so here's my 2x right here. This is 2x. This one right here is 3y. If I want to subtract those, what I'd end up with, I'd end up with a matrix that looks like this. I'd have 8 minus 27, negative 12 minus 8, negative 6 minus 0, and 0 minus negative 9. So in the end, if I wrote that out, I'd end up with negative 19, negative 20, negative 6, and positive 9. So there would be my result of 2x minus 3y. Hopefully that makes sense. Well, let's look at the next one. Let's say we wanted to add these two together. Instantly you should run and you should go, wow, wait a minute, there's a problem here because this is a 2 by 2 matrix and this one's a 2 by 3 matrix. That's a problem. They need to be the same. So you can't do it, so we call this undefined. Or does not exist. DNE stands for does not exist. Okay, hopefully that makes sense. It wouldn't make any sense because so you'd add 1 to 10 and negative 2 to 0, but what the heck would you do with the 14? And you'd run into the same problem in the second row. All right, so now we can also solve these matrices. When these things are equal, notice that y is equal to 2x minus 6. So if y is equal to 2x minus 6, and then we also know that x is equal to 2y. So x is equal to 2y. Well, now we can solve this. If we needed to figure out what, if the question was find x and y, well, now what we can do is we can solve this. We could say, okay, well, we know that if we merge these two equations together, we know that y is equal to 2 times 2y minus 6 because we just substitute 2y in for x. And if we go through and solve this, we get y is equal to 4y minus 6. Subtract 4y, negative 3y equals negative 6. Divide by negative 3, y is equal to 2. So if y equals 2, then x must be 2 times 2, or x is equal to 4. So we got x equals 4, y equals 2. So we can solve these because we can just compare specific parts. All right. One other thing that I wanted to kind of forgot to tell you is, let's say we had this matrix right here, and let's say we called this matrix A. And let's say I wanted to find A, and let's say I did 1, 2. If you saw this notation, A, 1, 2. If you saw this notation, one of the things you need to know is this is row 1. This is column 2. So row 1, column 2 in this matrix is negative 20 because it's row 1, column 2. So that's going to be an important piece if you're trying to figure out, if they ask you, tell me what A1, 2 is. That's something you're going to have to do. All right. So I'm going to give you these two. You can pause this thing, pause right now, and see if you can do these problems. Gives you a chance. I'll give you a chance to pause it. Okay, now if you've come back, you're trying to look for the answer, let me show you how to do this. So let's say we're doing this one right here, and we got 2 times this matrix here, so this would be 6, 0, 12. I don't think I made this long enough. 8. 2 times 17 is 34. And then 2 times negative 3 is negative 6. And we're still going to subtract 10, 1, 15, 20, negative 3, 13. So if you think about what this would be then, is then we'd have, this is 6 minus 10. This is 0 minus 1, 12 minus 15, 8 minus 20, 34 minus negative 3. Negative 6 minus 13. And if we finish this out, we'd end up with negative 4, negative 1, negative 3, negative 12, 37, and negative 19. And that would be our answer to that first one. Okay, so that's our answer to that first one there. And hopefully that makes sense. We took 2 times the first one, and then we just subtracted the second one, and we just compared the individual parts. Now, if we're going to do this next one, notice that you got these rows, right? You got this row right here. That's all equal to each other. So we know 10 is equal to 2x plus 4. We know that y is equal to x minus 8. And then finally, we know that z is equal to 2y plus x. And then you're going to solve it, right? You're going to try to solve this. Well, the easiest thing to do is to find x first, because x is the only one that has only one value in it. So we could do 6. If we subtract 4 from both sides, 6 is equal to 2x. So x must be 3. Well, if x is 3, we can take it, stick that in right there. And we can kind of go over here and say, okay, well then y must be 3 minus 8. Well, y is equal to negative 5. And then finally, we can take this 3, that's x, stick it in there. Take this negative 5, stick it in there. And we can say z is equal to 2 times negative 5 plus 3. So z must be negative 10 plus 3. So z is equal to negative 7. So then our solution to this, x is equal to 3, y is equal to negative 5, and z is equal to negative 7. Hopefully that makes sense. If it doesn't, go back and look at this again. Go back and watch it again. Make sure you've taken notes on this, because you're going to have to do a Delta Math assignment with this. And I wish you all the best. Good luck. Let me know if you need any help.